All right, let's talk about linear equations. Today, we're going to unlock them. We'll dive into the different ways you can write them, why each form is actually useful, and this is the big one, how to sidestep those common, sneaky traps that can trip up just about anyone. So here's our game plan. We'll kick things off with why these equations even matter in the real world. Then, we'll cover the three main forms, learn how to switch between them, and tackle 4 super common mistakes. We'll wrap it all up with a clear path to success. Ready? Okay, section 1, more than just x's. Before we get lost in all the variables and numbers, let's get grounded in why any of this matters. You know, linear equations aren't just some abstract math concept, they're actually tools for describing the world all around us.
Let's take a real-world scenario. Say you're joining a gym. There's a one-time fee of $75 and then it's $25 a month. Well, this simple little equation, y equals 25x plus 75, perfectly lays out your total cost over time. The y is your total bill, and x is just the number of months you stick with it.
So what does this really mean for you? Well, it means we can basically predict the future. With this, you can figure out exactly what you'll owe after 6 months, or a whole year. You could even work backward and see how many months you can afford with a specific budget. Understanding the structure here is everything. Section 2, the 3 main forms. So how do we build these things? Well, there are 3 main ways. Think of them like different blueprints for describing the exact same straight line, but each blueprint has its own unique strengths. You've definitely seen this one before. Slope-intercept form, y equals mx plus b. It's so popular because it instantly gives you 2 key facts. M is the slope, that's your rate of change, and b is the y-intercept, which is basically the starting point. That gym membership equation? Yep, that was in this form. It's perfect for any situation where you have a starting value and then a steady change over time. Then you've got standard form, ax plus by equals c. This one really shines when you're working with 2 different things that add up to some total. Like, imagine you have $100 for movie tickets, and they come in $10 or $15 options. This form is great for figuring out all the possible combos. Plus, a cool little bonus, it can represent any line, even a vertical one, which slope-intercept form actually can't do. And finally, point-slope form. This is your go-to when you have a rate of change and just a single snapshot in time. Let's say you know a plant grows 2 centimeters per day, and on day 5 it was 12 centimeters tall. This form lets you build the entire growth equation instantly from just that one specific piece of info. So let's recap real quick. Slope-intercept is your best friend for problems with a clear start and a steady rate. Standard form is perfect for when you're combining 2 quantities to hit a total. And point-slope is what you grab when you need to build an equation from a single data point and a rate. Honestly, knowing which tool to use is half the battle. Okay, section 3, translating forms. Now, since these are all just different ways of saying the exact same thing, you've got to know how to translate between them. This is a huge skill, and it's all about moving things around with a little bit of algebra. So let's try one. We'll take an equation in standard form, something like 2x minus 3y equals 6, and we'll flip it into the much more graph-friendly slope-intercept form. Now, the single most important thing to remember here is that our one and only goal is to get that y all by itself on one side of the equal sign. First things first, we need to move that x term over. We do that by subtracting 2x from both sides. That leaves us with negative 3y equals negative 2x plus 6. See? Now, to get y totally alone, we just divide by negative 3. And you got to remember, you have to divide times every single term by negative 3. That gives us our final answer. Y equals 2/3 x minus 2. And just like that, we can clearly see the slope is 2/3 and the y-intercept is negative 2. Easy. All right, on to section 4, common math traps. Look, knowing the forms is one thing, but actually doing the math correctly is a whole other story. A lot of us fall into the same traps. So let's look at 4 of the most common ones so you can learn to spot them and, more importantly, avoid them. First up, messing up inverse operations. Take a look at this problem. So after you add 1 to both sides, you'd get 1/2 x equals 20. The work here then shows multiplying by 1/2 times again to get rid of it. Take a second. What's wrong with that picture? The mistake is using the wrong opposite. Multiplying by 1/2 is literally the same thing as dividing by 2. And what's the opposite of dividing by 2? It's multiplying by 2. So you should multiply both sides by 2, which gives you the right answer, 40. Next up is a total classic,
Integer arithmetic. It seems so simple, but man, it catches so many people. So after subtracting 3 from both sides, the work here says that negative 18 minus 3 is negative 15. Is that right?
Nope, not even close. This is a classic mix-up with negative numbers. Just picture a number line. If you're standing at negative 18 and you subtract 3, you're taking 3 steps further to the left, which lands you at negative 21, not negative 15. Okay, our third trap is what I call the partial operation. Let's say after subtracting 12, you'd get 4m equals negative 4. But some people might try to divide by 4 earlier, like you see here. The work shows them dividing times only the 4m term. What's the fundamental rule being broken here? So, this is maybe the golden rule of algebra. Whatever you do to one side of an equation, you have to do it to the entire side. You can't just pick and choose which terms get the treatment. It's all or nothing. You've got to divide both the 4m and the 12 by 4, the whole thing. And the final trap involves the order of operations, especially when you've got brackets. In this problem, the first step shown is trying to subtract the 8 from inside those parentheses. Is that the right move to make first? Absolutely not. When you're solving equations, you work in the reverse order of operations. That multiplication by negative 2 is outside the parentheses, so you have to deal with that first. The correct first step is to divide both entire sides by negative 2. And that brings us to section 5, your path to success. We've seen the blueprints, we've spotted the traps, so now let's build your personal toolkit. Success in this isn't about being a genius, it's just about building good habits. Here is your toolkit for success. First, write down every single step. Second, if you need to, brush up on your integer rules. Third, always, always, always apply operations to the entire side of the equation. And finally, always solve by applying the opposite operations in reverse order. If you can master these 4 habits, you're going to be in great shape. You know, we started with something as simple as a gym membership, but linear equations can model business profits, predict population growth, so much more. So the question isn't just about solving for X anymore. It's now that you have the tools, what real-world problems are you going to go out and solve?